Hello and welcome. In this tutorial I'm going to show you how you can create this effect inside the Houdini. So this tutorial is based on this video which has been done inside the light wave, and I'm going to show you how you can create this kind of effect inside the Houdini based on the request that I've received. And of course you can find the link of this video in the description. So let's go to the Houdini. Let's create a simple geometry here, and for example let's create a circle, and of course later you can replace it with your own logo or a letter or anything else, but for this tutorial a simple shape like a circle works for us. Let's change the primitive type to polygon, and also let's increase divisions. And currently, as you can see, I have only one primitive, so let's add a divide node to get more primitives for this circle. And of course let's disable the convex polygons and let's break the polygon. Okay, that's good. For the animation of each primitive and each division, we have to create a separate path, so it starts from the center of the primitive and it should go toward the positive z values. So the first thing is to find the position of the center position of each primitive. So let's create a for loop, and here let's select the beginning node and let's create meta import node. So what this node does is to give us information about the current loop and about the parameters of these loops nodes, and the most important things and the most important parameter for us is the iteration value. And as you can see here, we can have access to this parameter using the detail expression. So here I want to decrease the iterations number to 1, so I want to work on one primitive so you can see better what is going on here. So here let's delete all the primitives but keep a primitive that its number is equal to the current iteration. So let's choose delete by expression as the operation, and as the expression I can type the primitive number is not equal to detail and the name of this node, and the name of the parameter is iteration, and the index is 0. And let's merge the result with the result of the previous step and the previous iteration. And in this case, as you can see here, it gives us the first primitive or primitive number 0. Okay, let's check it here. Yes, it is primitive number 0. Now let's add a point at the center of this primitive. So let's use centroid expression, and the node is our delete one node, and the X value, Y value, and the Z value of the center. Okay, and let me disconnect this delete node from the merge, and let's connect the add node to the merge node. So here I have access to the center of this primitive. Let's create our path for the animation, and I'm going to use a line, and I want to copy it onto this point. So let's create a copy node, and let's connect it to the add point, and here let me connect the copy node to the merge node. And here I want to create a point node to create normal attribute for the center point. So it should be toward the positive Z values, and here also the direction of the line should be toward the positive Z values. Okay, let me increase the length of this line, and also let me increase the points along this line. Now let's create another copy, and let's copy the input primitive to these points. Okay, and as you can see here, we have an offset value, and let's create a transform node and connect it to this primitive, and let's set the pivot point at the center of this primitive, $CY and $CZ. Let's copy this parameter and paste the expression here, and let's multiply it by -1. Okay, now the faces are in place, and as you can see here, we have to create normal attribute for the points on the line. So let's create a polyframe node, and here I want to use tangent as the normal value. Okay, and I think we have to use bitangent to correct the rotation of these faces. Okay, and now I want to use a skin node to create a skin from these cross sections, and here as you can see, this cross section and the final geometry is open at the both sides. So let me create a polycat, and of course here you can use sweep node to create this kind of geometry. Okay, now the only thing that I have to do is to create a carve node here, and I can animate the extrusion of this face. Okay, so let's start with the value of 1 for the second view, and for the first parameter let's use 0. Let's create a keyframe at frame 1, and let's go to the, for example, frame 48, and let's decrease the second view, and of course let's go to the frame 1 and increase the first parameter. So we have this type of animation, and if you want you can offset the animation of the second parameter. So here, if I hold my shift key and click on this parameter, I can have access to the animation editor, and I can move this keyframe to frame 73, for example. Okay, that's better. Now the problem is that, as you can see here, the path of animation is a straight line, which is not very attractive, and just the result is not interesting. And now what we can do here is to create a point WAP node just before the carb node, and let's dive inside and create an anti-alias noise for the points. Okay, and let's add the 3D noise to the current position of the points, and of course we have to connect the position to the position of the points. Okay, so let's promote these parameters, and let's keep the amplitude parameter here. So let me increase the length of this line, and here we can also increase the amplitude of this noise. And let's adjust some of these parameters, and as you can see here, at the end of this animation the face is not completely at its original position, and that's because now with this noise the end position of the line is not aligned. So what we have to do is to create a magnitude attribute for each point. So for example, the point number 0 has the magnitude of 0, and we want to gradually increase the magnitude of the noise as we go toward the end of this line. So let me create an attribute for each point just before the point WAP node. Let's create attribute create node, and let's call it magnitude, and let's make it local variable. And as the value, I want to control the value using a ramp. So let me create a null node. Let's select the edit parameter and let's add float ramp to the parameters. And here let's call it magnitude also. And as you can see here, this ramp starts at the position 0 and the ends at the position of 1. So we have to remap the point numbers to this range from 0 to 1. So here, as the value of the magnitude, I want to use the channel ramp expression so I can have access to the value of this ramp based on the position. So the ramp, the name of the ramp is magnitude, and the position for each point is equal to $PT divided by the total number of the points minus 1. Okay, and the index of the ramp is 0. So here, using this expression, the point number 0 gets the value from the 0 position, and for example the point number 21 gets the value from the position 1. Okay, so here I want to go to the point warp node, and here I want to use this attribute to control the magnitude of the noise. So let's use get attribute node, and it should get the attribute from the current geometry, and the point number is the current point number, and the attribute is mag, and it is float type. And here I want to also add a multiply node, and let's connect it to the amplitude. Okay, and here let's increase this number, which is magnitude. So let me change the name of this parameters also to mag and mag. Okay, so let's choose another name like amplitude. Okay, okay, so here, as you can see, we can control the noise using this ramp. and if I increase this number, you can see that within this distance we don't have any noise, and we can control it using this ramp. Okay, let's add another point here, and let's change the interpolation to the P spline, and also let's change the interpolation of the last point also to B spline. And also this one to B spline. Okay. Let's decrease this number. And now you can see the animation. And also we can use the same value for P scale attributes. So let me copy this parameter and paste the expression here. Of course, we need to have full P scale value at the end, so here I can type 1 minus. Okay, as you can see, the scale of the cross section increases as we move toward the original position. Okay, now I can apply this animation to all of the faces. So here, let me create a null node, and let's rename it to underline inputs. And here, as the number of iterations, I can use the number of the primitives in the input node. Okay, now the only problem is that the animation is similar for all the faces, so we need to randomize it for each face. So here, let me copy this expression, and if you remember, this expression gives access to the number of current iteration inside the loop. So here, for the offset, let me copy the x value and paste it to the y and the z values. And here, let me paste this expression, and let's randomize it, and let's multiply it by for example 2000 to get different results for each faces. Okay, and as you can see here, can decrease this area in which we don't have any noise, and also we can increase the divisions of the line so we have more smooth transition. So let's increase it to, for example, 50. And the other problem is that we have to offset the animation for each faces. So here all the faces arrive at the original position at the same time. So here, after the carve node, let's create a time shift node. And again, let me copy this expression and paste it here. $f minus random value, a random value based on the iteration value, which is equal to the face number. So here we need to have an integer value, so let's use floor function and let's multiply this random number by 20. So we'll have a random number between 0 and 20. Okay, and as you can see now, they arrive at the original position with their random offset. Okay, so the only thing is that we have to create animation for the second part in which they leave the surface. So here what I'm going to do is to create another copy of this line. So here, just before the carve node, let's create a transform node and actually let me use it before the point swap, and here I want to rotate it 180 degrees along the x-axis. So we have this version of the line, and let's merge it to the original one. And as you can see here, we have two primitives, so let's use a join node to make a single line out of these two lines. So here we need to modify the animation of the carve node. So let's delete the keyframes and let's start using these values, and for example till frame 48. We animate the half of the path, and I want to be sure that I put the end of this line within this distance, in which the noise attribute is 0, and also let's offset it actually till frame 72, and let's keep these values, for example, till frame 96. Let's add another keyframe, and let's create the exit animation. So we have an animation like this. Okay, so let's see the result. As you can see, they come here, they have a stop here, and then they continue to move. Okay, I think that's all for this tutorial. What you can do as an exercise is to use different nodes to create the same effect. For example, try to make this effect using the sweep node, or maybe try the extrude node, and compare the speed of the simulation and the animation using these 3 different nodes: the skin node, sweep node, and extrude node. So I hope you enjoyed this tutorial, and I hope to see you in the next one.